So here we're going to start looking at algebra, and we're going to start with some basic equations, just ones that involve addition and subtraction. So before we get started, just a reminder as to what algebra is for. Right? And so algebra is there so that when we don't know a number yet, either because we haven't been told it or we haven't worked it out, we've got a way of accounting for it. And so what we tend to do is we tend to just use a letter to stand for a number that we either haven't been told or we haven't worked out. Okay, so if we only have one missing number, then we can use the rest of the information that we're given in the equation to work out what number has to go in that place. Okay, if we've got more than one missing number, then it becomes a little bit vague, right? We can't always answer it. So if we were to think about this, 3 plus something is 5. Okay, hopefully we can tell just pretty quickly from looking at that that something should be 2. Right? Instead of just drawing lots and lots of question marks in algebra, all we do is we use a letter instead. And so we've got 3 plus x is equal to 5. So we can use the rest of the information that's there to work out what number has to go in the place of that letter. And so x has to be 2. Right? That's the value that has to take. If we were feeling particularly fancy, we could use a Greek letter. We could go for symbols instead. So we go 3 plus theta equals 5. Right? The point is, it doesn't matter what symbol we put there, or what squiggly thing we put there. That thing still needs to be equal to 2. Right? So in this case, theta would be equal to 2. So all we're doing is just changing how we represent the missing part. Right? And all we're going to do here is work out what number goes in that missing place. So if we see questions like this, right, often what we just did there, the answer can seem very obvious. Right? It can seem very intuitive, and we can just, it is this. But what we need to do is we need to come up with a way of actually solving it in quite a formal way, so that when the equations become a little bit more difficult, we've got a way that we can fall back on that we know gives us the answer. Okay, so we're going to practice that with some of these easier ones so that we know it gives us the right answer, so that when we are a little bit less sure about ourselves, we know it's going to work and find the answer for us. Okay, when we're solving our equations, they need to be treated like a balance. Okay, everything on the left hand side of the equal sign is equal to everything on the right hand side. Okay, so insert the stock image from PowerPoint there. Right, the blue bottle on the left is equal to the 3 white ones on the right. Okay, so when we try and solve these, anything we're going to do to one side, we must also do to the other side. So, taking for an example, x plus 4 equals 7. And what I want is I want this unknown letter thing, this x, on its own. But I haven't just written x on its own, I've written x plus 4 on the left hand side. So in order to get rid of that, okay, we need to think about what its inverse is. When we talk about the inverse, it's just the opposite. Okay, so the inverse is a fancy word for opposite. So what's the opposite of adding 4? Subtracting 4. So if I subtract 4 from that left hand side, I'm just going to be left with x. But because we need to think about these as a balance, I need to subtract 4 from the other side as well. And 7 minus 4 is going to give me x equals 3. And if we go back to the top line and we think about it, 3 plus 4 equals 7, that works. That's the second example. We've got 3 plus y equals 13. And I just want to have the letter bit on its own. Right? Ultimately, my goal is to get it down so that I've got the letter bit, or one lot of the letter bit on the left hand side, and its value that it is equal to on the right hand side. So what's stopping me from just having y on its own? Well, it says 3 plus y. So I need to find the inverse here. I need to take away 3 because I've got 3 there. So I need to subtract 3 from the left. So I need to subtract 3 from the right. And so 13 minus 3 is 10. So here y is equal to 10. Thirdly, I've got z plus 25 equals 50. So again, we're thinking about the inverse. So what is the opposite of plus 25? It's subtract 25. And again, because I just want the letter bit on its own there on the left hand side. So I'm getting rid of this extra number bit. But when I do that, I've unbalanced my equation, so I need to get rid of the same amount from the other side. 50 minus 25 means z is equal to 25. If we think about something that involves subtraction, I've got x minus 3 equals 17. So here we need to think about what's the inverse of minus 3? What's the opposite of taking away 3? Adding 3. And so if I add 3 onto that side, I'm going to end up with nothing, right? Minus 3, add 3, gets me to the 0, right? That gets rid of the number bit that I wanted to. But because we treat these like balance, I need to add 3 onto the other side as well. Which means x is going to be equal to 20. So I've got 17 plus 3 there, giving me 20. 5, I've got y minus 3 equals 11. So it's the same idea. Right? I need to find the inverse of taking away 3. What's the opposite of taking away 3? The opposite of adding 3. Okay, and so when I add 3 onto that side, I've got minus 3, add 3, I get 0 again. But I need to do it to both sides, so I need to add on 3 there. 11 plus 3 is 14, so that means here y needs to equal 14. And what we can do is, once we've done these in this really formal way, we can check, and we can just start with the number, and we can put it back into the very first line we've got. So here, if I wanted to check, we've worked out that y should be equal to 14. So if I go back to the first line here, then it should be 14 minus 3 equals 11. And that should work. And it does. Lastly, z minus 2 equals 14. What is the opposite of taking away 2? It's adding 2. So when I add 2 onto that bit, it cancels out. It's going to give me 0. And I need to add 2 onto the other side. And so z is going to be equal to 14 plus 2. So z is equal to 16. Okay, so all we're looking to do in these questions is find the extra bit that stops us from just having the letter on its own. We're going to do the inverse to get rid of it. And remember that we need to do the same thing to whatever's on the other side of the equal sign.